Alright, this is Mrs. James, and today we're going to be talking about the second equation that we're learning in our physical science class. We're going to solve problems now that have acceleration in them. Our last problems, everything was happening at a constant velocity. Now things are going to be speeding up and slowing down. These look a lot like our recent problems, but they have a different equation and they have a different triangle. Just like before, if you were using the equations, you still use the equations. If you were using the triangle before, you still use a triangle. So now each of you will have either two triangles or two equations. You won't have to memorize these. They will be written either on the board or on the top of your test. You're just going to have to decide which is the right triangle or the right equation for each problem. As a reminder, acceleration tells you how quickly velocity changes. Here is the equation for acceleration. It is the change in velocity over time. In other words, things are speeding up or slowing down, so the velocity is changing. And we're comparing that to the time. So how quickly is the velocity changing? If the velocity changes a lot over a small amount of time, it's high acceleration. Here's how it looks with our abbreviations. This little F here, see how it's small and it's written down low there like that? It's a subscript. That stands for F is for final. This little I that's down low here stands for initial. So we could write the equation. Acceleration is velocity final minus velocity initial divided by time. Sometimes it's written like this. Instead of saying Vf and Vi, it says V2 and V1. It's the same thing. It just means the later on velocity minus the starting velocity divided by time. And sometimes it's written like this. See that little triangle? That means changing. So there, triangle, changing. Acceleration is change in velocity divided by time. This is a Greek letter delta, by the way, and scientists use it anytime they want students to find the change in something, and the change in is always the final minus the initial. So here we go. Final minus initial. Alright. So what happens if you get the final velocity and the initial velocity mixed up and you put them backwards? Your sign of your acceleration will be wrong. For you guys as freshman science students, a negative acceleration means it's slowing down. So if you get these two backwards and if you were reverse the final velocity and the initial velocity, and by mistake you say Vi minus V up, you might make it look like your object is slowing down when it's actually speeding up. Alright, here is our triangle for those of you who are using triangles. Again, you don't have to memorize, it will be given to you. Up on the top, you find the difference in velocity. So you take your final velocity and you minus your initial and you put it up top here. Acceleration goes here and time goes here. Now it's just like we were doing before with the equations. If you know one of the things on top, so if you know the change in velocity, you know this, and you know that, you divide them to get the time. If you know the change in velocity, you put it up here, and you can divide that by the time if you're trying to find the acceleration. And if you know the acceleration and the time, you'll multiply them by each other. So right here, if you know these two, you will multiply them by each other, and that will give you the change in velocity. Alright, so here's a couple sample problems. And I want you to think about what's the final and what's the initial velocity in each of these. A car goes from 20 meters per second to 40 meters per second in 5 seconds. So, and then it says what's its acceleration. So we've got 3 numbers in there, and I want you to think about which number in all these numbers is the final velocity and which is the initial. And we're going to go over those on the next page. A rolling ball goes from 5 meters per second to 2 meters per second in 6 seconds. What's its acceleration? A ball rolling at 10 meters per second will come to a stop in 2.5 seconds if it decelerates at what rate? An object accelerates from rest to a velocity of 24 meters per second in 20 seconds. What is its acceleration? So, let's take a look at those. Here's our first one. A car goes from 20 meters per second to 40 meters per second in 5 seconds. What's its acceleration? 20 meters per second, that's our initial velocity. 40 meters per second is our final velocity. So, in your equation, you'd say 40 minus 20 would be 30 meters per second. That would be our change in velocity. So, 40 minus 20 is 30. So you would use that for your change in velocity. I'm sorry, except the 40 minus 20 isn't 30, it's 20. Why didn't anybody tell me I did that wrong? 20 meters per second. That's a positive change in velocity because the object is speeding up. Alright, a rolling ball goes from 5 meters per second to 2 meters per second in 6 seconds. So it starts at 5, so that's our initial, and it goes to 2, that's our final. So it's not important which one happens first and which one is bigger and which one is smaller. It's what happens first and what happens second. So our final velocity is 2 meters per second. Our initial velocity is 5 meters per second. So our change in velocity is minus 3 meters per second. That's what you would put inside your equation or inside your triangle as a negative value. Well, that makes sense because the car is slowing down, or the rolling ball is slowing down. You'd expect to get a negative acceleration for your final answer. Alright, a ball rolling at 10 meters per second will come to a stop in 2.5 seconds. Alright, so here's our initial. Here's our final. Yep, it's not a number, it's a word, a stop. Well, when you're stopped, you're going 0 meters per second. So velocity final is 0 minus velocity initial is 10. So the change in velocity that you're going to put in your triangle is minus 10 meters per second in your triangle or in your equation. Again, it's slowing down, that's why it's negative. Alright, an object accelerates from rest to a velocity of 24 meters per second. Rest, another word, its number value is 0. It gets up to 24 meters per second. So this is our final velocity. 24 minus 0, 0 is our initial velocity, equals 24 meters per second. So that's what you would use inside your triangle or your equation. So in other words, when you're solving a problem, that's how you would find your final minus your initial velocity. Or right here, that's how you would find that number. Find the final velocity in your problem, subtract the initial, and put that number right there in your equation. Alright, let's look at a couple sample problems. A sliding object decelerates from 32.3 meters per second to standstill in 15 seconds. What's its acceleration? Same steps we used before. So let's fill them in. Alright. We know time is 15 seconds. We know our initial velocity is 32.3 meters per second. Here it is right here. We know our final velocity was standstill. That's 0. Alright, so initial velocity and final velocity. Trying to find acceleration. There is our triangle and our equation. So remember, most of you are using the equations. Here's the triangle. Rearrange it. We don't have to rearrange it. We're already solving for acceleration. Acceleration is change in velocity divided by time. So here's our change in velocity divided by our time. If you are using the triangle, up here you would find that change in velocity. So 32.3 minus 0 is 32.3. This is our unknown. This is our 15.0 seconds. So we divide 32.3 by 15. We divide 32.3 by 15. And our 3 sig fig answer is 2.15 meters per second squared. You may be saying to yourself, but wait a second, 0. Hey, is that 1 sig fig? Is that 0 sig figs? How come we didn't take it into account here when we did our sig fig answer? 0 is an exact number. It has an infinite number of significant figures. So you just ignore zeros when you do sig figs. Here's another one. How long will it take an object traveling at 20 meters per second to reach a speed of 35 meters per second if its average acceleration is 1.7 meters per second squared? So our velocity initial is 20 meters per second. Our velocity final is 35 meters per second. Our acceleration is 1.7 meters per second squared. We'll try to find time. There's our equation. There's our triangle. We rearrange our equation just like we've been doing with our simpler equation. Alright, so here's the equation the first time. Here it is rearranged for time. Numbers are plugged in. Here the numbers are plugged into the triangle. We have a 2 sig fig answer. Solving for time, so our units are seconds, 8.8 seconds. You're going to do a practice worksheet, and you're going to be solving some of these yourselves now.